Okay, this is the homework help video for Honors Math 3, Unit 2, Assignment 3. So we are going to start with question number 5. So for question number 5, so I'm just going to copy it down, we are looking for when the absolute value of 1 minus x squared is greater than or equal to negative 1, so when x is greater than or equal to negative 1 and less than or equal to 1. So we are looking to try to see if this value inside is positive or negative, so we can rewrite it without the absolute value. So our question is this section inside, is it a positive value or a negative value if the values for x are between 1 and negative 1? So I'm just going to pick a number somewhere between 1 and negative 1, so let's say we choose x is equal to 0. So if I choose x is equal to 0 and then evaluate, so just off to the side here, so I'm going to replace that x with 0. I would have 1 minus 0 squared, and so that would be 1 minus 0, or 1. So then that means that if I were to choose any number between 1 and negative 1, this number inside of the absolute value would always be positive. So then do I need absolute values around here? And I don't. So then for number 5, then this would be that this would be 1 minus x squared, so I don't need the absolute value. But that's only true if the values of x are between 1 and negative 1. Okay? And so that would be that question simplified. Okay? All right, so let's take a look at another one. So let's take a look at question number 10. So number 10. So for number 10, I have the absolute value of root 10 minus 3, and then minus 2 minus root 5, and then in absolute values as well. So again, I'm looking to see, are the numbers inside here positive or negative? So let's start with this part right here. Is that positive or negative? So I don't know exactly what square root of 10 is, but I know it's somewhere between 3 and 4. And that's because 3 squared is 9, which is smaller than 10, and 4 squared is 16, bigger than 10. So I know this right here is somewhere between 3 and 4. So 3 point something. So if I subtract 3 from it, so if I take, 3 point, whatever, and I subtract 3, that would give me a positive number, right? So that would be greater than 0. So that section there is positive. And then I want to do the same thing over here. So I want to know, is that positive or negative? So I have 2 minus, and then the square root of 5. So again, I don't know what the root of 5 is, but I know it's a number between 2 and 3. And that's because the square root of 4, which is smaller than that, is 2. And the square root of 9, which I also know, is 3, so 5 is between 4 and 9. So this number here has to be 2 point something. So 2 squared is 4, 3 squared is 9. So somewhere between 2 point something, right? So I don't know what, but I know it's 2 point something. So here I have 2 minus a number bigger than 2, because it's 2 point something. So 2 minus a number bigger than 2, so that would be a negative number, right? Because I have 2 minus a number bigger. So since this is positive, I don't need the absolute value, right? So that is positive, so I don't need the absolute value. And then now I have, I'm going to group it though, and then minus. And then this number right here is a negative value. So if it's negative, what would force a negative positive is another negative. So let me say that one more time. So if I want to drop the absolute value, I still want to make sure that number is positive. So if I just drop it, so that subtraction is different, right? So if I were to just drop the absolute value, then this number here would be negative, and I need to counteract that with another negative. So then I'm making the opposite of that negative value, which would be positive, which is the same thing the absolute value does. So this is the opposite of this negative number, which would turn positive, and that's what the absolute values do as well. Okay? All right, so now I'm going to go ahead and simplify. So the two negatives make a positive, And then there's like a 1 here, so if I distribute that in, or I just don't need the parentheses anymore. And then plus, and then I have 2 minus root 5. And then combine like terms. And then these cannot combine because they have a different value under the square root, and neither of those can be simplified. So that would be my answer. Okay. All right, let's do another one. So let's take a look at question number 16. So for this one here, I want to rewrite this into a piecewise function. So I have my original, so I'm going to start with the same exact equation, but my grouping symbol now is going to be parentheses. So there's my original. And then now I'm going to do my opposite. So this is the right leg, yes, that is staying the same, and then the left leg is get reflected, and so then this will become negative. So this section in here will become opposite. So I don't want to put the negative right here because that looks like subtraction, so I'm going to move it to the front. So I have my original equation where I change the absolute value grouping symbol to parentheses. And then this one's staying the original, and then this is the leg that gets reflected, so opposite. So now I have to create my if statements. So the original is only original if this is positive, right? So this original is only the original if this is positive. So I need this right here, right? So for my original, let me do that right here. The absolute value needs to be positive, so that's only going to be true when x minus 3 is greater than or equal to 0, because greater than or equal to 0 means you have a positive value. So then if I solve this, then I would have this is if x is greater than or equal to 3, right? So this is only positive, right? All of this right here. So this is only positive if x minus 3 is greater than 0, which is only true then if x is greater than or equal to 3. So now we do the opposite leg. So if I make this negative, I want to make sure to look for where this is negative. So then I have a double negative to turn positive. So I want to know when is this negative. So this is my reflected version, right, or my opposite version. So this will only be opposite if this right here is less than 0. So add 3 over. So if x is less than 3. Okay. All right, so I have my original. So the way you see it without absolute value. And then the opposite version, so when this is opposite. And then this is true when x minus 3 is positive, so that's when x is greater than or equal to 3. And then this is true when this is negative, so when x is less than 3. Okay. All right, and one more here. So we're going to jump down to number 24. Last one. Okay, so I always want to do GCF for these problems before I turn it into a piecewise, just to kind of help me out in the reducing later on. So I can factor a 2 out of both of those. Okay, so now I want to create my piecewise. So I have my original. So the top stays the same, and then the absolute value bars are going to turn into parentheses, so I'm going to group that differently. And then now I want to do the opposite version. Again, we're looking at the absolute value part, so the top is not going to change, right? But now I want to do the opposite version of the absolute value. So opposite, so that's the leg that gets reflected. So absolute value of x plus 5 turns into the original and then the opposite version. And so this is only going to be true if this is greater than or equal to 0, right? So when x plus 5 is greater than, and I said equal, but it can't equal because it's in the denominator, right? Because then if it equaled 0, we'd be dividing by 0. So this is only true if this part is positive. To say that's positive means to say it's greater than 0. So that means x has to be greater than negative 5. And then now for the opposite version, the only way this would be true is if this part right here was negative. And to say it's negative is to say it's less than 0. Right? So I can only have the negative out here is if this is also negative, so meaning less than 0. Okay, so then once I get to here, then, sorry, just got a text, so I'm doing bad things. Okay. So right here, so once I get to here, then I can go ahead and reduce this. So let me go ahead and reduce this right now. So I'm going to jump over to here, squeeze it into the corner. So the x plus 5 is reduced down to 1. So this would be 2 times 1. So this would be 2 if x is greater than negative 5. And then over here, x plus 5's cancel. So then I would have 2 divided by negative 1, which is negative 2. And that's if x is less than negative 5. Sorry, my hand is covering on the edge. There we go. So then now this is what I have to graph. So let me get some graph paper here. So I'm going to go to where x is negative 5. And these are my y values. So I'm going to go where y is 2 and negative 2. So at the negative 5, if I want to be greater than negative 5, so heading to the right, that would be when y is equal to 2. So I'm going to go up to where y is equal to 2. And I'm going to head to the right. And then my y value is negative 2 when x is less than negative 5. So negative 2 when x is less than negative 5. So that would be to the left. And there's my graph. Okay, so that's it for this video.